Hello everyone, welcome to Math is Fun. Our lesson for today is all about multiplying and dividing monomials. At the end of this lesson, you are expected to learn product of powers, specifically multiply numerical powers, multiply algebraic powers, and multiply monomials. As well as you will learn quotient of powers, specifically divide numerical powers, divide algebraic powers, and lastly, divide monomials. First, we're going to study about the first law of exponents, and this is the product of powers property. This property states that if a to the m multiplied by a to the n, this is equal to a to the m plus n. To multiply powers with the same base, add their exponents. To understand further the first law of exponents, which is the product of power property, let's study the following examples. The first one is simplify 4 to the cube times 4. So, in this example, as we can see that the second factor, which is 4, is not having an exponent, but understood the exponent of 4 is 1. Let's find the product, as the rule says that if we multiply with the same base, add the exponents. So, 4 raised to the exponent of 3 plus 1. And the answer is equal to 4 raised to the exponent of 4. Then we're going to use the numerical products. So this is 4 times 4 times 4 times 4. 4 times 4 is equal to 16, times 4 is equal to 64, and times 4 is equal to 256. And this is the final answer. Another example. Simplify 2 to the 5th times 2 to the squared. Okay, so as we can see that the bases are the same, we're going to add the exponents. So 5 plus 2 is equal to 7. We're going to copy the base, which is 2. So this is 2 to the 7th. And using the numerical products, 2 to the 7th is equal to 108. Alright, we already know how to multiply numerical powers. This time, we're going to study about how to multiply algebraic powers. For example, simplify the expression x to the 9th times x to the 5th. So, as we can see that our bases are also the same. So this time, we're going to add the exponents. So, x raised to the exponent of 9 plus 5. And the answer is equal to x raised to the exponent of 14. And this is our final answer. Another example. Simplify the expression b to the 10 times b to the 3rd power. So we have b to the 10 times b to the 3rd power is equal to b raised to the exponent of 10 plus 3. And the final answer is equal to b raised to the exponent of 13. Since we already know how to multiply algebraic powers, this time we're going to multiply monomials. Okay, when we say monomial, it is consist of one term. For example, simplify negative 4y cubed times 2y squared. So, let's multiply. So, negative 4y cubed times 2y squared. We're going to separate the numerical coefficient of y cubed, which is negative 4, and the numerical coefficient of y squared, which is 2. So, we have here negative 4 times y cubed times 2 times y squared. So, let's combine the constants, which are negative 4 and 2. So, the quantity of negative 4 times 2 times the quantity of y cubed times y squared. So, let's simplify. Negative 4 times 2 is equal to negative 8. Y cubed times y squared. The same base, we're going to add the powers. So our final answer is negative 8y raised to the exponent of 5. Another example. Simplify the expression 3x to the fifth times the quantity of negative 2x to the cube. So, let's find the product. 3x to the fifth, this is equal to 3 times x fifth, times negative 2x to the cube, this is equal to negative 2 times x to the cube. Then, let's simplify. The quantity of 3 times negative 2 times the quantity of x times x cubed. So, let's simplify. The quantity of 3 times negative 2, this is equal to negative 6 times x raised to the exponent of 5 plus 3. And the final answer is equal to negative 6x raised to the power of 8. Next, we're going to discuss about the quotient of powers property. So, in this property, it states that a to the m divided by a to the n is equal to a m minus n. To divide powers with the same base, subtract their exponents. First, we're going to discuss about dividing numerical powers. For example, simplify 4 to the fifth divided by 4 to the second power. So, as we can see that the bases are the same, so we're going to subtract the powers. So, 4 raised to the exponent of 5 minus 2. 5 minus 2 is equal to 3. So, we have 4 raised to the exponent of 3. Then, let's simplify. 4 raised to the exponent of 3, this is equal to 4 times 4, which is equal to 16, times 4, which is equal to 64. And this is our final answer. Another example. Simplify 5 raised to the fourth power divided by 5 raised to the second power. So, let's subtract the exponents. 5 raised to the fourth power minus 2 is equal to 5 squared. So, 5 squared, this is equal to 5 times 5. And the final answer is equal to 25. Next, we're going to discuss about dividing algebraic powers. So, for example, simplify a to the sixth divided by a to the second power. So, we have the same bases, then we're going to subtract exponents. So, a raised to the exponent of 6 minus 2, which is equal to a to the fourth power. And this is our final answer. Another example, simplify m to the ninth power divided by m to the fourth power. So, let's subtract the exponents. M, 9 minus 4. And the final answer is equal to m raised to the fifth power. Next, we're going to discuss about dividing monomials. For example, simplify 10 raised to the exponent of 10 divided by 3x raised to the exponent of 7. So in this example, we're going to separate the numerical coefficient and the literal coefficient. So 15 divided by 3 and x raised to the power of 10 minus 7. So our final answer is 15 divided by 3, which is equal to 5. X raised to the exponent of 10 minus 7 is equal to x raised to the exponent of 3. And this is our final answer. Another example. Simplify 20y raised to the exponent of 12 divided by 5y raised to the exponent of 5. So, we're going to separate the numerical and the literal coefficients. So, 20 divided by 5, y raised to the exponent of 12 minus 5. So, let's simplify. 20 divided by 5 is equal to 4. Y raised to the exponent of 12 minus 5 is equal to y raised to the exponent of 7. And this is our final answer. I hope that you understand our lesson for today, and thank you for watching.